burnout developer in Vienna built a WhatsApp bot in a few hours, open sources it. It goes viral in November 2025. January 2026, Anthropic sends a cease and desist, forces a rebrand with days of notice. February 2026, OpenAI hires him, the fastest-growing GPT repository in history. 2 weeks later, security researchers discover something terrifying: 135,000 exposed instances, 820 malicious plugins, one-click remote code execution, attackers already stealing API keys at scale. Welcome to the agent era, where a single burnout project became enterprise IT's worst nightmare in 90 days. I'm Alex, this is the Read AI, and today we're breaking down how OpenClaw went from hero to security crisis and what it means for the future of AI agents. Joining me is Dr. Rachel Kim. Rachel is a security researcher who's been tracking the OpenClaw situation since the first vulnerabilities dropped. Rachel, welcome.
Thanks, Alex. This has been one of the wildest security stories I've covered.
So, for people who haven't been following this closely, give me the 30-second version. What is OpenClaw and why should anyone care?
OpenClaw is an AI agent that runs on your computer, not in a browser, not in the cloud, on your actual machine. It can control your apps, click buttons, execute commands, read your files, and it does this all autonomously, without asking permission for every single action.
So, it's powerful.
Extremely powerful. That's why it went viral. Developers loved it because it actually worked. But that power is also why the security community is panicking right now.
Let's start from the beginning. So, who built this thing?
Peter Steinberger, he's a 40-year-old Austrian developer, runs a company called PDF Technologies that he sold for reportedly close to $1 billion. Very successful, very respected in the developer community.
So, not some random hacker in a basement.
No, this is a serious developer with serious credentials, and he was burnt out. Late 2025, he's tinkering with WhatsApp automation just to decompress, builds a bot that can actually do things, book appointments, manage tasks, handle his digital life.
And he open sources it.
November 2025, posts it on GitHub as Claudebot, a play on Claude, Anthropic's AI. Within weeks, it's one of the fastest-growing repositories in GitHub history. Developers are installing it, modifying it, building on top of it.
What made it special?
It actually worked. Most AI assistants just talk. They give you answers, suggestions, maybe write some code. Claudebot could control your computer. It could open apps, click buttons, fill out forms, send emails, execute commands. It was the first widely accessible autonomous agent that felt real.
And then Anthropic got involved.
January 2026, Anthropic sends a cease and desist. The name Claudebot is too close to Claude. They demand he rebrand with days of notice.
How did Steinberger react?
He was furious, called it the worst form of online harassment I've experienced, because as soon as he changed the name, crypto scammers hijacked the old name Claudebot and started distributing malware versions.
So Anthropic's legal move actually made the security situation worse.
Immediately worse. People were downloading fake versions thinking they were getting the legitimate tool, and Anthropic refused to let Steinberger set up redirects or warnings. They wanted the name completely dead.
So what did he rebrand to?
First Moltbot, then finally OpenClaw, in what he called a Manhattan Project-level secret rebrand because he didn't want scammers to front-run him again.
And then OpenAI comes in.
June 15, 2026, Sam Altman announces OpenAI is hiring Peter Steinberger. They beat out Meta, which reportedly offered mid-nine figures, potentially over $100 million. Microsoft's Satya Nadella called personally.
Why did he choose OpenAI over a 9-figure payout from Meta?
He wanted to keep it open source. That was non-negotiable. OpenAI agreed. Meta didn't.
So Anthropic's cease and desist pushed the fastest-growing agent project directly into the arms of their biggest competitor.
That's exactly what happened. And now we're dealing with the security consequences of that.
All right, so when did security researchers start raising alarms?
Same week as the OpenAI hire, late February, multiple teams independently disclosed serious vulnerabilities.
Walk me through the main one.
CVE 2026-25253, CVSS score 8.8, which is high severity. It's called hijacked, and it enables one-click remote code execution.
Explain what that means in practice.
You're browsing the web, you click a link, could be in an email, a Slack message, a Reddit post. That's it. Game over. The attacker now has full control of your OpenClaw instance, which means full control of everything OpenClaw can access.
And how does that work technically?
OpenClaw runs a local WebSocket server on your machine, usually on port 18789. The vulnerability is that this server trusts localhost connections without proper validation.
And anyone can connect to localhost?
Here's the trick. Modern browsers allow external websites to open WebSocket connections to localhost, so a malicious website's JavaScript can connect to your local OpenClaw instance, steal your authentication token, and take over the entire thing.
Wait, I thought localhost was supposed to be protected.
That's the assumption that broke. The OpenClaw developers designed it thinking localhost equals safe, but browsers don't enforce the same cross-origin protections on localhost that they do for regular websites.
So what can an attacker do once they have access?
Everything OpenClaw can do. And OpenClaw can do a lot. It can execute shell commands, access your file system, read your messages across every platform you've connected: WhatsApp, Slack, Telegram, email. It holds API keys for AI services, cloud providers, development tools.
This is sounding really bad.
It gets worse. Once the attacker has the authentication token, they can use the API to disable safety features. They send a request to turn off user confirmation, so OpenClaw stops asking, "Are you sure?" before executing commands. Then they escape the Docker container that's supposed to sandbox the agent, forcing commands to run directly on your host machine.
So all the security guardrails come down in milliseconds.
The researchers who discovered this demonstrated the full attack chain, from clicking a link to complete system compromise, in under 3 seconds.
When was this patched?
Version 2026.1.29, released January 30th. But here's the problem. As of last week, over 50,000 are still running vulnerable versions.
Why haven't people updated?
Shadow IT. Most OpenClaw installations are developers running it on their personal machines or work laptops without telling IT. There's no centralized patch management, no automated updates. You have to manually pull the new version and rebuild.
So this is still actively exploitable.
Right now, yes. And that's just one vulnerability.
You said just one vulnerability. How many are there?
Multiple CVEs disclosed over the past few weeks. CVE 2026-24763 is a command injection vulnerability. CVE 2026-27001 is a workspace path sanitization issue that enables prompt injection attacks. And there's a broader class of problems around the plugin ecosystem.
Tell me about the plugins.
The OpenClaw has a marketplace called ClawHub where developers can publish skills, basically plugins that extend what the agent can do. In early February, security researchers audited 2,857 skills. They found 341 that were definitively malicious.
What does malicious mean in this context?
Exfiltrating data, stealing credentials, establishing backdoors, crypto mining, the usual malware playbook, but in plugin form.
And people were installing these.
Yes, because the marketplace had basically no vetting. Anyone could publish a skill, and users trusted that if it was on ClawHub, it was safe.
Has that gotten better?
Actually worse. The most recent audit found 820 malicious skills. That's up from 341. It's being called Claw Havoc, a supply chain attack, where attackers are flooding the marketplace with malicious plugins.
So even if you patch the core vulnerabilities, you might have installed malicious plugins.
Exactly. And those plugins have the same level of access as the core agent. They can execute commands, access files, call APIs.
How many total OpenClaw instances are out there?
Internet scanning finds about 135,000 exposed instances. That's just what's visible from the internet. The actual number of installations is much higher because most people run it on private networks or localhost.
What percentage of those 135,000 are vulnerable?
Conservatively, at least 50,000 are running versions with known critical vulnerabilities, and that doesn't count the plugin problem.
So we're looking at tens of thousands of compromised or compromisable systems.
At minimum, and these aren't random home users, these are developers, often at major tech companies, with access to source code, production systems, customer data.
That's a massive blast radius.
It's one of the largest shadow IT security incidents I've tracked.
All right, because what we're describing isn't just a technical vulnerability. This is a case study on how AI agents break traditional security models. Most AI coverage focuses on what models can do, benchmarks, capabilities, performance. We're covering what happens when those capabilities hit the real world and start breaking things. If you're running OpenClaw or any AI agent, this episode is critical. If you're in enterprise IT trying to figure out how to handle AI tools,
So you got 50,000 plus vulnerable instances. Why can't traditional security tools catch this?
Because AI agents operate in a fundamentally different way than traditional software. Let me break it down. First, detection. Most endpoint security tools look for known malicious binaries, suspicious network connections, unusual process behavior. But ClawClaw is a legitimate developer tool. It's supposed to execute commands, access files, make network connections. That's its job.
So it looks like normal behavior.
Worse than that, it looks like privileged power user behavior. A developer running shell scripts, accessing multiple cloud services, moving files around, that's Tuesday. EDR tools don't flag it because it's within the normal range of developer activity.
What about network monitoring?
ClawClaw uses WebSockets for communication. Encrypted WebSocket traffic looks like any other HTTPS connection. You can't easily inspect what's being transmitted without breaking the encryption. And even if you could, how do you tell the difference between legitimate autonomous agent action and attacker-controlled agent action?
Intent analysis?
That's the holy grail, but we're not there yet. You'd need to understand what the agent is trying to accomplish with every action and evaluate whether that intent is malicious. Current tools can't do that reliably.
What about traditional authentication?
This is where it gets really interesting. AI agents represent a new identity class, non-human identities that hold credentials and take autonomous actions. They're not users, they're not service accounts, they're something in between.
And we don't have good models for governing that.
Not yet. If a human logs in from an unusual location, that's suspicious. If an agent makes 1,000 API calls in an hour, is that suspicious? Or is that just the agent doing its job?
So the normal heuristics break down.
Completely. And it's worse with ClawClaw specifically because it's designed to aggregate credentials. It holds your Anthropic API key, your OpenAI key, your Google OAuth tokens, your Slack tokens, potentially your AWS credentials, your GitHub personal access tokens, all in one place.
One compromise gets you everything.
Right, and because it's running on a developer's machine, it likely has access to source code repositories, internal documentation, maybe production deployment credentials.
What about the fact that it's running locally? Doesn't that limit the attack surface?
You'd think so, but the hijacked vulnerability specifically exploits the fact that it's local. The attacker doesn't need network access to your machine, they just need you to visit their website. Your own browser makes the connection to localhost on their behalf.
So localhost equals safe is actually localhost equals vulnerable.
In this architecture, yes, and that's a fundamental challenge for locally run agents. They need to be accessible locally for users to interact with them, but that local access can be hijacked.
Let's talk about the enterprise angle. How are companies dealing with this?
Most companies don't know they have a claw problem. That's the core issue.
Shadow IT.
Exactly. Research from Token Security found that 22% of monitored organizations have employees running ClawClaw without IT approval.
1 in 5 companies?
And that's just what they could detect. The actual number is probably higher. Developers install it on their machines, it works great, they tell their colleagues, it spreads organically.
So how does IT even know it's there?
Network scanning can find instances listening on port 18789. EDR tools can detect the ClawClaw process and installation artifacts redirects in the .claw directory. There's an MDNS broadcast on port 5353 that advertises the service, and you can query Shodan or Census for internet-exposed instances.
But if I'm a developer running it locally with no external exposure, I'm invisible.
Pretty much, until something goes wrong.
What does something goes wrong look like in practice?
Here's a real scenario. A developer at a mid-sized tech company installs Claw to help manage their workflow. They connect it to Slack, GitHub, their cloud provider console. They install a few skills from ClawHub. One of those skills is malicious. It exfiltrates the developer's GitHub personal access token. That token has write access to the company's main repository. The attacker uses it to inject malicious code into a library used across multiple projects.
Supply chain attack.
Enabled by a compromised AI agent that IT didn't know existed. And here's the kicker. The developer probably doesn't know their agent is compromised. It's still working fine for them. The exfiltration happens in the background.
How do you even investigate that?
With extreme difficulty. Traditional forensics assumes you're looking at human actions, logins, commands, file access. But here, everything is agent actions. You've got API calls, autonomous workflows, background tasks. Reconstructing what happened and separating legitimate agent behavior from attacker-controlled behavior is incredibly hard.
What should enterprises be doing?
First, visibility. You need to know where Claw is running. Network scans, EDR queries, employee surveys. Get the actual scope. Second, patching. Any instance running a version before 2026.1.2 is critically vulnerable. Priority 0, patch within 24 hours. Third, credential rotation. If a vulnerable instance was accessing any internal systems, assume those credentials are compromised and rotate them. Fourth, policy. You need a governance framework for AI agents. What can they access? What approval do they need? How are they monitored?
Is anyone actually doing this?
Some of the more sophisticated security teams, yes, but most companies are still in the "we didn't know this existed" phase.
Let's circle back to Anthropic for a minute, because there's an irony here that I don't think has been fully explored.
I know where you're going with this.
Anthropic sends a cease and desist over trademark concerns, forces a rebrand that creates chaos, crypto scammers, malware versions, confusion in the ecosystem, pushes Steinberger towards OpenAI, and now we have a massive security crisis involving an OpenAI-affiliated project.
From a pure strategic perspective, the cease and desist was catastrophic. Anthropic could have embraced the community building on their platform. Steinberger was making Claude more useful, more accessible. Instead, they chose legal enforcement.
And the result?
The result, the most viral AI agent project in history, ends up with their chief competitor and carries their chief competitor's brand into hundreds of thousands of installations.
Did Anthropic gain anything from this?
They protected their trademark. That's it. Meanwhile, OpenAI gets credited for supporting open source agents, gets the best agent developer in the ecosystem, and gets massive mindshare in the agent space.
What could Anthropic have done differently?
They could have worked with Steinberger, offered to sponsor development, provided API credits, helped secure the project early, built a relationship with the agent developer community.
Instead, they chose confrontation.
And from a security perspective, that confrontation contributed to the chaos. The rapid rebrand happened so quickly that it created confusion about which repositories were legitimate. That confusion was exploited by malicious actors.
So Anthropic's legal strategy has indirect security consequences.
I'd argue direct consequences. The rapid rebrand under legal pressure created exactly the conditions that malware distributors exploited, and Anthropic's refusal to allow redirects or warnings made it worse.
Has Anthropic commented on any of this?
Not publicly. They've been silent on the security implications of their enforcement actions.
That silence is interesting.
Very interesting, especially given that Anthropic positions itself as the safety-focused AI company. This is a case where legal safety, protecting the trademark, directly conflicted with actual safety, protecting users.
Let's zoom out. What does this OpenClaw crisis tell us about the agent era we're entering?
3 big takeaways. First, agent security is fundamentally different from application security. We need new models, new tools, new frameworks. The old playbooks don't work.
What specifically breaks?
Authentication, authorization, monitoring, incident response, all of it assumes human actors or well-defined service accounts. Agents are autonomous. They aggregate credentials. They operate at machine speed. They make decisions without human approval. Every part of traditional security needs to be rethought.
Second takeaway.
Open source agents will proliferate and we're not ready. Claw went from 0 to 135,000 plus installations in about 90 days. That's faster than most enterprises can even evaluate a new tool, let alone secure it.
And these are sophisticated developers installing it.
Right. These aren't naive users clicking on phishing links. These are people who know what localhost is, who understand WebSockets, who can read code, and they still didn't catch the security implications until researchers disclosed them.
What does that tell you?
That agent security is subtle. The risks aren't obvious, even to experts, which means when agents become mainstream, when less technical users start deploying them, it's going to be much worse.
And third takeaway.
The next stage of AI competition is going to be fought on the agent battlefield, and security is going to be a major differentiator.
Explain that.
Right now, AI companies compete on model capabilities, benchmarks, context windows, cost. But as we move to agents, security and trust become critical. If your agent gets hacked and leaks customer data, it doesn't matter how good your model is.
So companies that solve agent security have a competitive advantage.
Massive advantage. Enterprises won't deploy agents at scale if they can't govern them, audit them, secure them. Whoever solves that problem first gets the enterprise market.
Who's closest to solving it?
Nobody has fully solved it, but the companies taking it seriously are building centralized governance platforms, single sign-on for agents, policy enforcement, audit logging, credential scoping. The ones treating agents like just another app are going to get burned.
Is OpenClaw fixable?
The specific CVEs, yes, they're already patched, but the architectural challenges, local host trust, plugin security, shadow IT, those are harder. Claw would need to fundamentally rethink how it handles authentication, how it validates plugins, how it enables enterprise management.
Are they doing that?
Not publicly announced. Remember, Steinberger is now at OpenAI. It's not clear what happens to the independent OpenClaw project versus what OpenAI might build on top of it.
So the future of OpenClaw is uncertain.
Very uncertain, and that uncertainty extends to every agent project. We're in the early days. Things are moving fast. Security is lagging behind innovation.
Rachel, final question. If you're a developer who's been running OpenClaw, what do you do right now?
3 things immediately. 1. Update to version 2026.2.26 or later. Don't wait. 2. Audit what credentials and access you've given it. Assume anything it touched might be compromised. 3. Talk to your security team. Get ahead of this.
And if you're in security?
Assume you have OpenClaw in your environment, even if you think you don't. Scan for it, find it, then decide whether to secure it or shut it down.
What about the bigger picture?
We're entering the agent era, whether security is ready or not. OpenClaw is the canary in the coal mine. It showed us what happens when powerful autonomous tools proliferate faster than security can adapt. Every company building agents needs to learn from this.
Otherwise?
We're going to see this same pattern repeat. Viral agent tool, rapid adoption, security crisis, scramble to patch. Better to get ahead of it now.
Pause. For everyone listening, the chatbot era is over. The agent era is here, and the security model is broken. This isn't about one vulnerability in one tool. This is about an entire new class of technology that our existing security frameworks can't handle. Understanding that deeply, understanding the attack vectors, the governance gaps, the strategic mistakes, that's not optional anymore. Subscribe to the Read AI because we're going to keep tracking this as it develops. This is the most important security story in AI right now, and most coverage is just scratching the surface. Share this with your security team, your engineering managers, anyone running AI agents, because OpenClaw is everywhere, and most people don't know it. Rachel, thank you for breaking this down.
Thanks, Alex. This is important work.
I'm Alex. This is the Read AI, and we'll catch you on the next one.